Have you ever looked through a window and wondered, how is this even here? This perfectly clear, solid material that we take for granted every single day. Glass is literally everywhere in our homes, our cars, the phones in our pockets. But how do we get from a pile of sand to a perfectly transparent pane of glass? It's a fascinating journey of fire, chemistry, and incredible engineering. Let's dive in and uncover the secrets of how glass is made. It all starts with a surprisingly simple recipe. The main ingredient, making up about 75% of the mix, is silica sand. But this isn't the same sand you find at the beach. It's a special, high-purity quartz sand that's been ground into a fine powder. Beach sand has too many impurities like iron, which would give the glass a greenish tint. So, we start with super clean, pure silica. But silica sand alone isn't enough. It has an incredibly high melting point, over 1700 degrees Celsius, or 3000 degrees Fahrenheit. That's hotter than volcanic lava. To make it melt at a more manageable temperature, we add a special ingredient called a flux. The most common one is sodium carbonate, also known as soda ash. This stuff lowers the melting point of the silica to a much more achievable 1000 degrees Celsius. Now, if we only use silica and soda ash, the resulting glass would be a bit of a problem. It would actually dissolve in water. Not very useful for a drinking glass or a window, right? So, we need to add a stabilizer. This is where limestone, or calcium carbonate, comes in. It makes the final product much more durable and resistant to water. So, our basic recipe is set: silica sand, soda ash, and limestone. These three ingredients form the basis for what's called soda-lime silica glass, which is the most common type of glass, making up about 90% of all the glass produced in the world. But wait, there's more. Often, another key ingredient is added to the mix: cullet. What's cullet? It's just a fancy word for crushed, recycled glass. Adding cullet is a huge win-win. It melts at a lower temperature than the raw materials, which saves a ton of energy. Plus, it's a fantastic way to recycle and reduce waste. In fact, many modern glass plants use a mix that contains a large percentage of cullet. Once all our ingredients are gathered, the silica sand, soda ash, limestone, and cullet, they're carefully weighed and mixed together in a giant machine. This mixture is called the batch. Getting the proportions exactly right is crucial for the quality of the final glass. Now for the really hot part. The batch is transported and fed into a massive furnace. And when I say massive, I mean it. These furnaces can hold hundreds of tons of molten glass and run 24 hours a day, 7 days a week, sometimes for years at a time without ever shutting down. Inside, temperatures soar to around 1500 degrees Celsius, or 2700 degrees Fahrenheit. It's an inferno in there. As the batch enters the furnace, it melts into a thick, glowing, honey-like liquid. It's a mesmerizing sight, like a river of liquid fire. The molten glass is kept at this extreme temperature for a while. This allows any bubbles to rise to the surface and escape, and it ensures that all the ingredients are perfectly blended together. This process is called fining. Any impurities either burn off or sink to the bottom. What's left is a perfectly uniform, bubble-free molten glass, ready for the next stage. So, we have this giant pool of glowing, liquid glass. How do we turn it into the shapes we need? This is where the magic of forming happens, and there are a few different methods depending on what you're making. Let's start with the most common one for flat glass, like for windows and mirrors. It's called the float glass process, and it is pure genius. The molten glass is poured from the furnace onto a shallow bath of molten tin. Yes, you heard that right, liquid metal, why tin? Well, tin has a very high density and a perfectly flat surface when it's molten. The glass, being less dense, floats on top of the tin, spreading out to form a perfectly flat, uniform sheet. The force of gravity pulls the glass down, making it incredibly smooth, while surface tension keeps the thickness consistent. The width of the glass ribbon is controlled by the speed at which it has drawn across the tin bath. It's an incredibly precise process that creates the flawless glass we see in our buildings and cars. As the ribbon of glass floats along the tin, it begins to cool down. It moves from the furnace end, which is hot, to the cooler end of the tin bath. By the time it reaches the other side, it has cooled enough to become solid. But the cooling process isn't over yet. If glass cools too quickly, it can develop internal stresses, making it weak and easy to shatter. To prevent this, the newly formed glass sheet enters a long oven called a layer. This process is known as annealing. Inside the layer, the glass is carefully reheated and then slowly and precisely cooled over a long distance. This relieves any internal stresses and makes the glass strong and stable. This step is absolutely critical. Without proper annealing, the glass would be practically useless. Once the glass emerges from the layer, it's at room temperature. It's then inspected for any flaws using scanners and lasers. Any imperfections are marked. Finally, the continuous ribbon of glass is cut into large sheets by automated cutters. These sheets are then ready to be shipped off for further processing, like being coated, toughened, or cut into smaller pieces for windows, doors, and more. That's the process for flat glass, but what about bottles and jars? For that, we use a different method called molding. The most common technique is the blow and blow or press and blow process. A precise amount of molten glass, called a gob, is dropped from the furnace into a preliminary mold, called a blank mold. In the press and blow method, a plunger presses the gob into the shape of the neck and a preliminary body. Then, this partially formed shape, called a parison, is transferred to the final mold. A jet of compressed air is then blown into the parison, expanding it like a balloon until it fills the mold, taking on its final shape. In the blow and blow method, it's similar, but compressed air is used in both the blank mold and the final mold to shape the glass. This entire process happens incredibly fast. A modern bottling plant can churn out hundreds of bottles and jars every single minute. Just like with float glass, these newly formed containers have to go through an annealing layer to be slowly cooled and strengthened. After that, they undergo rigorous inspections. Machines check for cracks, thin spots, and any other defects before they are packed and sent to be filled with our favorite drinks and foods. And what about glass fibers, the kind used for insulation or in fiber optics? That's another process entirely. For fiberglass insulation, molten glass is spun at high speed, like making cotton candy. This forces the glass through tiny holes, creating super thin filaments that are then bound together. For fiber optic cables, it involves drawing a very pure, specially constructed glass rod, called a preform, into a hair-thin fiber that can transmit data with light. It's amazing to think about the versatility of this one material. From a simple mixture of sand, soda ash, and limestone, we can create everything from massive architectural windows to tiny, intricate bottles and hair-thin fibers that connect the world. The technology has come a long way from the ancient glassblowers who painstakingly crafted each piece by hand. While the art of glassblowing is still alive and well, creating beautiful, unique works of art, the industrial processes we've talked about are what allow glass to be such an integral, affordable, and essential part of our modern lives. So the next time you look through a window, pick up a glass, or use your phone, take a second to appreciate the incredible journey it went on. From a fiery furnace to a perfectly engineered final product, the story of glass is a testament to human ingenuity. It's a process of turning humble sand into something truly transparent, strong, and beautiful. Thanks so much for watching. If you found this journey into the world of glass fascinating, don't forget to hit that like button and subscribe for more deep dives into how the world around us works. Let me know in the comments what material you'd like me to explore next. See you in the next video.